To do all of these problems, you should recognize that each of them you are given grams of a material and you're asked to find grams of another material. So keep in mind that if that's what we want to do, if we're given grams of material A, keep in mind the only way to find another material is to be in moles of that material so that we can get to moles of a different material. So remember, this is how we started our unit, using what was called the mole to mole ratio, and we used the coefficients from the balanced reaction to get there. And so then our final step, once we have gotten to moles of the other material, our final step will then be that we use the molar mass to get to grams of material B. So if we do this the traditional way, we are going to have to do 3 steps. We're going to start with grams of this material. We're going to need to convert that to moles. Then we're going to use the coefficient from the balanced reaction to convert from moles of A to moles of B. And then we're going to use the molar mass of B to convert from moles of B to grams of B. That'll be our traditional method. Now, if we want to do the way where we create our own conversion factor, then we need to remember what the balanced equation tells us. The balanced equation here says that we've got 2 moles of KClO3. So if we want to know how many grams that is, we're going to have to take the molar mass of KClO3 and multiply it by 2 in order to know how many grams this particular balanced equation is telling us. This says 2 moles of KCl. So again, we would have to take that molar mass and multiply it by 2. This says 3 moles of oxygen. So again, we would have to take that molar mass and multiply it by 3 in order to create our own conversion factor. So I will do both methods. I'll do the classical method as well. I'll do in green the method where you create your own conversion factor. So in black here, I have the traditional method, 3.76 grams of KClO3. I'm going to convert that to moles using the molar mass of KClO3. I'm going to use my mole to mole ratio in order to get over to oxygen, and then 1 mole of oxygen weighs 32 grams. Then in green here, I have the method where you create your own conversion factor. Remember that this says 2 moles. 2 moles of KClO3 would weigh 245.1 grams, so that goes on the bottom here. I want to find my grams of oxygen, so that's what's going on the top here. If I look at my balanced equation, it says 3 moles of oxygen. Well, 3 moles of oxygen would weigh 96 grams, so that's what goes on the top. No matter what way you solve this, you're going to get 1.47 grams of oxygen as your answer for this problem. For the next problem, I am given grams of KCl, and I want to find grams of KClO3. So again, here's my traditional method. Starting with grams of KCl, I use the molar mass in order to convert to moles of KCl. Then I use the mole to mole ratio from the coefficients of the balanced equation. And then I want to convert to grams of KClO3. So the molar mass of KClO3 goes on top. 1 mole weighs that much. If I want to do this the method where I create my own conversion factor, I'm given grams of KCl. So I come up here, I see 2 moles of KCl. 2 moles of KCl would weigh 149.1 grams. So that goes on the bottom, so I get rid of grams of KCl. I want to find my grams of KClO3. Well, 2 moles of KClO3 would weigh 245.1 grams. No matter which way you solve it, you should get the same answer. 49.3 grams of KClO3 would be needed if you started with 30 grams of KCl. Next problem, I'm given grams of KClO3, so I want to find grams of KCl. My first step is to use the molar mass of KClO3 to convert into moles of KClO3. Then I use my mole to mole ratio in order to change from KClO3 over to KCl. Then I want to find grams of KCl. So the molar mass of KCl is 74.55 grams. So now I can calculate how many grams of KCl will be formed. If I want to do the other method, I start with grams of KClO3. So grams of KClO3 is going to go on the bottom. I go up here, I see 2 moles of KClO3 would weigh 245.1 grams. I want to find grams of KCl, so grams of KCl needs to go on the top. I'm going to go up here and see 2 moles of KCl would weigh 149.1 grams, so that goes on the top. And you get an answer of 1.66 grams of KCl. Okay, we're going to switch gears to a new chemical reaction, but all of these problems are the same thing happening. We're given grams of iron, and we need to find grams of a different material. We're given grams of oxygen. We need to find grams of a different material. We're given grams of iron. We need to find grams of a different material. So these are all going to work the same way. I'll continue to show both ways. So the first thing I have set up is the classical method. First, I need to take my grams of iron and use the molar mass of iron to find out how many moles of iron I have. Then I'm going to use the coefficient of the balanced reaction of iron. I want to get to iron oxide, so the coefficient of iron oxide goes on the top. Then I use the mass of iron oxide. 1 mole of iron oxide weighs 159.88 grams, so that's going to give me my grams of iron oxide. The other method of solving this problem, I'm going to use the balanced equation to find out how many grams of iron the balanced equation. Well, the balanced equation says 4 moles, so 4 moles of iron would weigh 223.73 grams. So I don't want grams of iron, so it's going on the bottom. I want to find out how many grams of iron oxide, so I'm going to look at the balanced reaction. It says 2 moles of iron oxide. 2 moles of iron oxide would weigh 319.73 grams. So you get 61.02 grams of iron oxide as an answer. For the next problem, I've got my grams I'm given of oxygen. I'm going to use the molar mass of oxygen to convert to moles of oxygen. I don't want oxygen, so I'm going to use the coefficient from the balanced equation. I want to get to iron oxide, so the coefficient of iron oxide is 2. Then I want to find out how many grams of iron oxide. Well, 1 mole of iron oxide weighs 159.88 grams. If I like the other method, I'm starting with grams of oxygen. So I'm going to go up here. I'm going to see 3 moles of oxygen would weigh 96 grams. So that's what goes on the bottom. I want to find grams of iron oxide. So I go up here. 2 moles of iron oxide would weigh 319.73 grams. And my answer would be 56.62 grams of iron oxide. My last one, I'm given grams of iron, so I'm going to convert that to moles. The molar mass of iron is 55.93. Then I don't want moles of iron, so moles of iron goes on the bottom. I want to get to oxygen, so moles of oxygen goes on the top from our balanced equation. Now that I'm in oxygen, I'm going to use the molar mass of oxygen to find out how many grams of oxygen would be made. If I like the other method, I've got my 125 grams of iron that I'm given. I'm going to come up here. I don't want iron, so 4 moles of iron would weigh 223.73 grams. So that goes on the bottom because I don't want it. I want to find my grams of oxygen. 3 moles of oxygen would weigh 96 grams. So that's what goes on the top here. So you're going to get an answer of 53.64 grams of oxygen. Again, if you're struggling with these, try to erase them, try to do them on your own, and then you can always check back here to see if you're doing them right.